Okay, so section 4.4, special products. Uh, we're going to be looking at some kind of rules that you can memorize to make your life a little bit easier and faster. So let's look at A here. Expand the following perfect square. Remember, x plus y squared is equal to x plus y, x plus y. So I can expand the binomial just like that. Okay. We'll just do like the first one, and then I'm gonna, instead of doing all 6 examples, I don't think somebody's gonna watch a 1-hour video if I go through every example. I'll go through like the first one and maybe like the last 2, just because usually the ones at the end are a little bit harder. So here, let's expand this. So again, this is like x plus 5 times x plus 5. Okay, and now well, 2 things you can do is you can expand it out, x squared, and then 5x and 5x and 25. Or you can just remember what we said before. The first term is just this squared, the variable squared. The middle term is just added together, so plus 10x. And the last term is the 2 terms multiplied together. Okay. Okay, so let's do that again. So let's go for this one here. So again, first term squared, -6 and -6 is -12. And -6 times -6 is plus 36. Okay. Let's do this one because it looks a little bit differently. So the first term squared. Okay. I could do the same idea. So the first term squared would just be 4x squared. The middle term would be 3. Okay, that wouldn't work. Let's just expand this one out then. Okay, so 2x minus 3, 2x minus 3. Okay. And then what you would do is you multiply, so you got your 4x squared, and it's just foiling it, right? So -6x, -6x, and then +9. And then these two group together, so you get 4x squared minus 12x plus 9. Okay, so what do you notice here? So what you should notice with these answers here is the first term is just a perfect square, right? Because the first term is squared. And the last term is also a perfect square here as well. Okay, so that's pretty much it. The first and the last terms are perfect squares. Okay. So there's a general rule here. So kind of might look confusing, but we have our binomial squared. We can expand it out, which is also, if you remember this, first term squared. The middle term is just xy, so xy is going to be the first coefficient and the second coefficient times 2, and then the last term is a perfect square as well. Okay. I think this xy is more obvious here. So you have 2 for the x, right? Well, I know this says x here, but they're talking about the first term. And the second term here, so 2 times 3 is -6 times 2 gives you the -12, right? So that's how they got the -12 here. And then obviously the y squared is just going to be the -3 squared, which is 9. And the x squared here is just this term squared, which is going to be 4x squared. Okay, let's look at factoring perfect square trinomials. Okay, so it says, use what you've learned to factor the following. Okay. Okay, so I guess they just want us to learn, we just want to use this, so the first and the last term are perfect squares. So this here, you can say what number squared, and again, they tell you it's a perfect square trinomial, right? So this rule applies to perfect square trinomials, right? So what number multiplies itself gives you 49 and adds to 14? So simply 7, right? 7 times 7 gives you 49. So you can write it this way. Or you can just write it x plus 7 squared, just like that. Okay. Same sort of thing here. So what number times itself gives you 121 and adds to 22a, or 22. So it's going to be 11, right? There we go, simply like that. Let's just move on to maybe number 6, because number 6 might be a harder one. They usually will end. So what two numbers multiply is, so this is actually the same thing. To multiply to 36 and that's to 12, we got y plus 6 here. Okay. And this is the same thing as y plus 6 squared. Okay, so there we go. So use what you know to find the missing value in the following perfect square trinomial. So this part might be confusing, so let's go through all 3 steps here, or questions. So they're asking us to find k value. So you can say what number multiplied by itself gives you 144, and you know, because it tells you it's a perfect square trinomial, right? So you know that this number is going to be the addition of the number itself. So the factor multiplied by itself that gives you 144 is going to be 12, right? So you know x times, and again it could be, I'm going to write positive, negative 12, because it could be 12 times 12 positive, or it could be 12 times 12 negative. So the answer, k, so 12 plus, if it's 12 positive, it's going to be, k is going to be 24, right? Or it could be negative 24, right? Because if 12 is negative, negative 12 times negative 12 still gives you 144, and negative 12 plus negative 12 gives you negative 24. So k could be 2 things. So let's try that similar sort of thing again. So what number multiplied by itself gives you 25? And you know 5 times 5. So you know that the value is going to be 5. So here we can write down, for example, a plus or minus 5 and squared, right? So if you multiply the binomial twice, it will give you this. So if k could be positive or negative, sorry, not k, but if this factor could be 5 positive or negative, that means k could be either 5 plus 5 or 5 minus 5. So that means k can equal positive or negative 10, right? Okay, last bit here. So now this is a little bit different. Now we're figuring out a number squared gives you k. So here, and then adds to negative 18. So since it's a perfect square trinomial, we know we can just divide this number by 2. So divide this by 2, and then we get negative 9, right? So we know that negative 9 squared will give us k. So negative 9 times negative 9 gives us 81. So k is actually equal to 81, and just positive 81, because negative 9 times negative 9 is always going to be positive 81. And just to show you the binomial, it would be y minus 9 squared, right? Okay, next page. Okay, expand the following. Again, these are special cases. So if you just did it normally, like, you know, a times a is, you're foiling it out, a squared, then a times negative 3 is negative 3a, positive 3a, and then negative 9, and then you get a squared minus 9, right? So you get something like that. But we're gonna notice a pattern if you do this. So you notice that this cases we're using binomials that are opposite. So this is called difference of squares, and we'll kind of go over this rule. So let's do a couple more. So let's just do, you know, I'll do this one, and I'll do maybe the last one, because the last ones are usually a little bit more tricky. So instead of writing it out in steps like that, you can just say the first term is squared. So m times m squared. And the middle term is going to cancel out. So we went over this in previous note, but it'll cancel out. So you can see here, if I did it out, they're opposite. So you get negative 3a and positive 3a. So nothing's there, right? Same thing here. If I did the steps out, it would be negative m and negative 6m and positive 6m, because m times negative 6m, and 6 times m is positive 6. So they cancel out. And the last term is squared. So negative 6 times positive 6 is negative 36. Right. So that's pretty much the pattern here. So you can see that you can do it out, or you can just do it in one step. So here, for example, if you use a pattern, first you'd have to recognize, like, hey, difference of squares. You got the negative binomial and the positive binomial. Everything else is the same. So if you notice that, you can simply just square the first term. So 10 times 10 is 100. And then you got your x squared. And you know the middle term is going to be missing because they're the same binomial, but the opposite, I guess, the negative. So the last term is going to be negative y times y, which will give you negative y squared, right? Yeah. But yeah, so what's the pattern here? And maybe we'll just do one more here. Just t, and I'll expand this out. So t times t is t squared. T times 7 is plus 7t. Negative 7 times t is negative 7t. And then finally, negative 7 times positive 7 is plus 49. These cancel out. Negative 7t, positive 17, you're left with t squared plus 49. Okay? So, and this is a t, not a plus sign. Plus and t look the same. Okay, so what do you notice here? So, middle term cancels out. Yeah, so there's no middle term here, right? Or here. And lastly, you also have the first term and the second term are both perfect squares, or I guess the last term. I'm just going to say that. So first and last terms are perfect squares. Okay, so that's called difference of squares, and that's the general form, right? So if you have same binomial but opposite, the middle term goes missing, and you get negative square, but the first and last term are perfect squares. Okay, so let's go on to the next part here. So factoring difference of squares. Okay, use what you have learned to factor the following. Okay, so this looks very similar to what we just did, but when you recognize, so you have a question that says perfect square here, and then negative perfect square here, you can simply say square root of this, square root of this will give you the first term and the second term. So m is the first square root of m squared, and the square root of negative 100. So we get plus 10, and we get the opposite of minus 10. Okay. And the other thing to note, you can't square root a negative number. I'm just square rooting the 100, right? Because then you get 10, and then you know that they're going to be opposite because we recognize this as difference of squares. Square root of 100 doesn't really work, right? Because what number times itself gives you a negative number. Can't do that. All right, so let's do a few more examples here, and then maybe I'll do number 2, and then we'll do number 6 because again, usually the last one's a little bit harder. So let's find the square root of the first term and the second term. So we get r, and we know it's negative. So even before this, you need to recognize the difference of squares. So r minus 9 and r plus 9. Okay. So let's do this one here. So first off, I recognize that this is a perfect square and this is a perfect square, and they're minus, right? It has to be negative. So difference of squares, cool. So square root this term, square root this term. So here we got 5 is the square root of 25, and you have a, so 5a. And the square root of 9 is 3, and then we have a b, so minus 3b, and 5a plus 3b. Okay, there we go. Let's just do this section here now, last part, and then we're done. I think that's it for chapter 4. Factor fully. Use what you've learned about common factors, factoring, and special products for the following. Okay, so we'll just do all 3 of these questions because I guess this is the trickier part. So here, right off the bat, I can say, hey, perfect squares, right? But to make your life easier, even before you do the perfect squares or difference of squares, you need to simplify. Okay, so I'm going to simplify this by taking out a common factor. So I know the biggest GCF is 4. So 4, and then we get 25, 4 times 25a squared gives us that. 4 times negative 4b squared. Yeah. Okay, now we can find, we got a perfect square, perfect square. You can leave the 4 on the outside. So the square root of 25a squared gives us 5a. And the square root of negative 4b gives us negative and positive 2b. Okay. And you can write the opposite as well because of the different square rule. Okay, there we go. Okay, so I'm running out of space on this one. But in this one, well, I'll try squishing it in. Okay, so the first step here is I'm going to simplify. So take a common factor out. So I can see 3 goes into everything. So 3x cubed. Oh, actually, you can see they all have an x as well, right? So you can write down 3, did it again, 3x, right? This is why you use pencil, not pen, but pencil seems to not show up really well in the document camera. So 3x, okay. So 3x times 1x squared gives us 3x squared, or cubed. 3x times 6x gives us 18x squared. And finally, 3 times 9, 3x times 9 gives us 27x. So we got that. And now what we're going to do is two numbers that multiply to 9 and add to 6. So 3 times 3 works. Yep, so 3 times 3. So this 3 on the outside, we're just going to keep it on the outside for now. But we know that we got the x over here. So 3 times 3 gives us 9. So x plus 3. And then the other one was x plus 3 as well. Okay, there we go. And that's it.